Okay, ladies and gentlemen, introduce Jean-Pierre, who has done so much for us with his receiving software.
Good evening, everybody. As you will hear, I am not an English speaker. So I will talk about MiniTioune, MiniTuner, and the future, the MiniTioune Pro. I don't know. I will change perhaps the name. It will be perhaps only MiniTioune 2. We will see. Last year we tried to create a receiver, a DVB-S receiver for DATV, especially because the Technotrem card disappeared from the market, and also the Narrowband DVB asked some special tools to receive symbol rate below 1 megasymbol. And most of set-top boxes are not able to receive under 1 megasymbol. So the idea was to develop a little receiver using different components, and especially a NIM, Network Interface Module. NIM is the little box you can see inside any set-top box or inside your TV that have inside different chips, a zero tuner that can be set to any frequency on the L band, and the DVB demodulator that will do all the job. And you will get directly the data output in parallel. So the idea for the MiniTuner was to use a NIM and a mini module from FTDI to convert the parallel data to the USB interface. I have chosen two special NIM that have a chip that was well known by me, that was able to do many things, and after tweaking it, to be able to go down to a very low symbol rate. So we are obliged to choose NIM that have STV 0903. So in 2015, I have selected three kinds of NIM. A Samsung for my first prototype, and after we have found Sharp and Datec that the BATC shop has sold, and there are some NIM from Sharp that are remaining. In 2016, I have also used two other NIMs, one from LG and one another from Serit with a newer chip, the STV 0913. My first prototype in March 2015. As you see, it's very simple. You have the NIM, you have the power supply, and just the converter, parallel converter to USB. That's all. It's a very simple structure. The USB converter. This was the schematic I have used. We have the NIM pinouts at the top, the mini module, just NAND to process, to know when the data are enabled on the bus, are valid on the bus. And directly, the bus is sent to the FT2232. This mini module, if we look at what it can do, we will see they can run 2 channels at the same time. One channel is used for I2C, conversation with the NIM. So it's by this way I can give orders to change the symbol rate, the frequency, and so on. And also, this is by this way that I can get all the information about the measurement. The constellation, the RF level, noise level, and so on. So there is a very big traffic permanently on this I2C bus. I was obliged to develop a special driver for that, to be sure not to get to take too long times to get the answer. And the second channel is used only as a FIFO. We have some buffer to receive the data from the NIM, the transport stream, to send it directly to the PC. So there is only 2 channels available on this mini module. It is important for the next slide we will see. So we have built mini tuners. We can see the mini tuners made with the PCB made by Brian and sold by the BATC. We have been able to use also a little PC called Pipo. It's not very expensive, and we can receive in a mobile station using this little PC. It's the touchscreen. It's HD, so we can have a good result. So, in April 2015, the first version of MiniTioune, the software to receive, was that. It was very complicated, too much things for people that have never used it. And I used VLC. When I receive a transport stream, I use VLC to send the transport stream to VLC. VLC shows us the video. At the bottom of the screen, we can see all the measure about the ref level, the lock situation, about the carrier lock and the symbol rate lock, the RF level, the MER, the constellation, and the VTRB errors. And all the LEDs tell you at the bottom right that you are getting the transport stream. You can show it if you want. MiniTioune version 4.2 in September 2015 was able to display itself the video. We have at the left the setup of the frequency, the different frequency we want to choose. We can write directly the frequency and the symbol rate. In the middle, the video. At the bottom of all the measure. And at the right, the system used to decode the video We can choose the PID, the codec. You can choose MPEG-2, H.264, or all can be done in an automatic mode with a button at the top right, Auto PID. If you do that, the computer will find. There is a button. This is the standard mode. And this is the expert mode. The expert mode is always a Boeing. So it's a little complicated, too much. And after using this software, in this year, appear the 0.4 version, and the expert mode has only what is very important to look at when we are searching to get a station. We have now this new little black rectangle with the graphic that show where the derotator is. When you want to lock on a station, you never give the exact frequency, and also the tuner is not set on the good frequency. There is a step. We can see it. Well, I am lucky here because the frequency set is exactly. I am lucky because it's just a multiplication of the step. But sometimes we are outside, and there is a double loop inside the chip, software loop, that try to lock on the symbol rate and to lock on the frequency. So here we can see a zigzag ramp that is doing the software to find the signal. You are waiting. You have asked this frequency, but he is searching and waiting to find a signal. You can change the range of this search with this scan strategy. You can change the range. You can also, I have a mode loop that asks to the derotator. Sometimes he's searching and staying in this side. So each 8 seconds, I ask him to start again on the frequency we want. We hope to receive someone. The range of this scanning can be very large, can be at 1 megahertz from the frequency you have asked. So this is the expert mode that has all what we need to look about the signals, the lock, and the strategy we use to lock on a station. We are now locked, so we can see in expert mode. We are locked. We can see the video. We have the constellation, MER, RF level. And when we are locked, we can switch to go back in the standard mode now to see the video. You can see also the video in full screen mode if you want. Oh, slide. We have to touch something. Oh. I don't know where I am. Qu'est-ce que j'ai fait? Okay, thank you. Now, today, this is the version 05. There are something different. I am receiving here HD, only at 2,000 symbol rate, kilo symbol per second. And the constellations are not the same. Because now I can receive DVB-S2. Oh. You can see the change. Now you can choose DVB-S, DVB-S2, or an automatic mode that will find itself if it is DVB-S or DVB-S2. You have more fake options. The TV mode that has been found is written, DVB-S2. And also, if it is DVB-S2, you can have not only QPSK, but 8 PSK. For that reason, we have this constellation. It's no more QPSK. In that example. This is DVB-S2, QPSK also. You don't recognize me? It's me when I was young. No, when I was 50. I have made many shows all over France, Germany, Belgium. I was doing some show using baby carriage. They are all baby carriage were synchronized by radio. So we were three musicians playing and synchronized with synthesizer, drums, and so on, electronic drums. And we have made, it was very pleasant. And now, what can we do with DVB-S2? We have, with DVB-S2, you have 4 modulation modes, QPSK, 8 PSK. You have also 16 APSK, 32 APSK. But if you continue to use a sharp or a harder technique, or I can say a standard set-top box, you don't have the possibility to receive these two modes. The only standard, low standard, used only in DVB-S2, QPSK, and 8 PSK. Using DVB-S2, we have also an improved coding system that allows to correct more error. We don't have only a Viterbi and read Solomon like in DVB-S, but we have an LDPC code and BCH code. We have also the possibility to have long frame and short frames for people who use the DATV Express. You will see in the menu the different kind of setup. But only long frame can be received with a standard NIM or a standard set-top box. You have also new several code rates. Using DVB-S, we start with this value. We have, for example, this new value. This new value had the possibility to receive signals very inside the noise, I can say. But they are not offered in a standard NIM. You can set them in your DATV Express, but you cannot receive using a Sharp or a HardAttack or standard set-top box. But you will have some new value. So this it's for it could be something interesting for us, perhaps. But if we stay with a Sharp or a HardAttack, we cannot use them. We have also different roll-off possibilities. Can say the way the signal is filtered, the shoulders are filtered. Yes. And you have also ACM and VCM. VCM is not very important for us. It's mainly for broadcast stations that broadcast a stream with different multiplexed data. So we can accept to give more bandwidth for this data than for this data if you have different station, different TV station on the same frequency, multiplexed. So it's not for us. But ACM could be something interesting. ACM allow to change the FEC in real time during the transmission. But for that, you need to have a feedback. The feedback could be the tune monitor. You know, when we are using MiniTioune or TuTune, you have a button that sends all the data to a website. So we could think that we could develop the software on the web that will send back this data to the station, the transmitting station, that will change in real time the FEC to be able to be received without errors. This possibility is not offered by a standard NIM. So, should we use DVB-S2? I can say many things. It's very new. I have no time to make many tests. So we are at the beginning. My first test gave me a result that if you are using standard high symbol rate, 4 megasymbol, for example, you can expect a gain by using DVB-S2. But when I go inside the narrow bandwidth world, I think today that with a standard NIM also, it's important, very important. If we stay with a sharp or BATC, DVB-S2 at SR 250 is not better than DVB-S. Because I suppose, the chip in the standard NIM is done that not be able to work below 1 megasymbol. I have been able to tweak it to change some parameters very outside the data sheets of the manufacturer. Very far. It's very strange, but it works in DVB-S. And in DVB-S2, they don't work. In DVB-S2, I am obliged to keep the standard setup of the manufacturer. So I have more noise. The MER is not, I say, at narrow bandwidth, when I play narrow bandwidth. So we will see. All is to test now. It's not only my part, it's your part. And we can see with what I call now a standard NIM, we have some different thing we cannot do. Last new software in 2016, Noel asked me to do it. I have developed the noise power measurement software we can use it with the MiniTioner. This software, if you don't know it, it's a software that allows you to measure directly the sun noise coming inside the MiniTioner using your dish and your tracking system. So, with my tracking system, I have a software that tells it to follow the sun, and it tells it, you follow the sun, but 10 degrees before, 8 degrees before, 6 degrees before, 2 degrees before the exact azimuth, and 0 degree, the exact azimuth. The azimuth plus 2 degrees, plus 4 degrees, and so on. And this is for azimuth, this is for elevation. And if I get a beautiful pyramid, I'm sure my tracking system is well set. With this system, I have used the AGC as I have switched off the automatic AGC of the chip, the DVB-S chip, and I use it as an attenuator, manual attenuator. So now, the new new MiniTioune Pro or MiniTioune 2, or it's not the SuperTuner. SuperTuner is just a dream today. SuperTuner could be very expensive, more expensive. We have some risk to take to create a SuperTuner. And I thought that it was better to have a step between MiniTuner and SuperTuner. SuperTuner will be a solution with all we can dream, specific chip that can do all what we want. Some filters on IQ, especially for low symbol rate. Today, if you look at MiniTioune, you will see that the filter that inside the NIM cannot go down below 10 megahertz. 2 times 5 megahertz for I and 5 megahertz for Q. So it's too wide to be very efficient for us when we are playing narrowband DVB. So the idea in the SuperTuner is we don't use a NIM, a standard NIM. We use the chip, the zero tuner chip, the demodulator chip, but between both chips we add a filter that will be able to give a very narrow bandwidth, and that will allow perhaps to be able to have a spectrum analyzer and so on. So SuperTuner is today always a dream. We continue to think about it, but this is the step we are today. Today, MiniTioune Pro. This is my first prototype of MiniTioune Pro. As you can see, I have two coaxial. Two coax, the two F plugs are both inputs. Because in this new NIM, professional NIM, we have a dual tuner that is able to receive at the same time two frequencies, two different frequencies. And also, if you see on my prototype, I have used two PCB from BATC. It's why I buy many PCB from BATC. They are happy. Yes, because we have also in this NIM two demodulators. We can demodulate at the same time two different transport streams. One signal in DVB-S and another in DVB-S2 if we want, and so on and so on. And we have inside two multiplexers that allow us to choose which input go to which tuner. Both input can go to the same tuner. We can exchange, we can do many things. And at the end, we have two demodulators. We can choose also with the multiplexer which demodulator output on this USB plug or which tuner output on this USB plug. Because I was obliged to put two converter, mini module converter to convert the parallel stream to USB. Donc, this NIM is a Serit FTS 4335, two RF inputs, two ZIF tuners, wide bandwidth, very exciting wide bandwidth, we will see. Two DVB-S demodulators, advanced. Advanced, it's very important. We will have all what is in red in the slide before. So we have the SuperTuner is an STV6120. The demodulator is the decoder STV0910 alpha. The alpha, the A is very important. And you can see we have 2 channels for 2 transport streams at the same time. And the channel for the I2C. So I need 3 channels if I want to use all the possibility of this new NIM. But do we need really all the possibility? I call this NIM Pro because there is an A, advanced. We have the code rates we don't have with the standard NIM, this new code rates, you remember. We have the possibility to decode 16 APSK and 32 APSK. We can receive short frames. We can work in ACM mode, adaptive coding and modulation. And also, this chip is done with with low symbol rate optimization. So I suppose I have not yet today, I have not time to test it in DVB-S2. But I suppose that in DVB-S2 it will be really better at low symbol rate. I don't want to hear my English accent. So, this dual tuner can receive from 134 megahertz up to 2450 megahertz without any converter. So you could receive the 2 meters band with this NIM without converter. Yes, you will need an LNA, perhaps and filters, perhaps, but you don't need a converter. You can receive directly the 2 meters band with it. You can receive the 70 centimeters band, you can receive the 23 centimeters band, and you can receive the 13 centimeters band. Ham TV, for example. I don't want to. So the question is, I have my NIM. I can put out 2 transport streams. What do we do? We can, as you see, I need 3 channels. 1 channel for the I2C data, 1 channel for the TS out of TS transport stream 1, and 1 channel for the transport stream 2. So we have 2 options: to use 2 USB plugs, or we stay with another solution where we can decode and show 1 transport stream, and the other transport stream is sent out to the parallel plug for people who want to put a little second FT and 2232 to translate in DVB, in USB mode, or to send directly to DATV modulator, a repeater, and so on. As you can see, if you take this pinout, you see you have the two parallel transport streams. So it's easy to use the standard, the old PCB for the first MiniTuner, for MiniTuner 1. And you put yourself somewhere because the pinouts are not exactly the same than a sharp, because you have now 40 pins, not 26. So the schematic could be the same. We could live with the schematic, and we could have a MiniTuner 2 that will be able to receive DVB-S2 with the new option, and that we will also be able to receive two frequencies at the same time. We can switch them to send this frequency to the demodulator that is displayed, or to send the other to the parallel output. The software. This was the hardware. The software, MiniTioune Pro. MiniTioune Pro, as you can see, we have two MiniTune in one. So I have two 2D rotators that are searching for a signal. This derotator has found the good frequency. It is decoded, and we see the video. The second demodulator will continue to search if he can receive something. And now both demodulators are locked. This on 400 symbol rate, and this at 250. And you can show the first demodulator, and if you click this, you will show the second demodulator. I've just clicked this button. When you click this button, this demodulator is shown, or this demodulator is shown. It's decoded and displayed. In standard mode, you can also see the transport stream 1 or transport stream 2. You can also, you choose which RF plug you are using. So if you want, the same RF plug can be sent to both demodulators. So you can display one and send the other to the parallel plug. All. Yes, I have changed. I display one, I display the second. And also, if I press the UDP buttons, I can display with two VLC. At the same time, you can see both video. And here, both audio. So it's not, it's not always present. So, next step. The NIM is easy to buy. We can buy 100 units. But we have 3 options. So I ask you, what do you prefer? The first option is simple. We just take this PCB and just adapt the way we plug the NIM. And we will have a MiniTuner with more possibilities, that's all. The second possibility is to use 2 USB modules, not FT2032. It can be 1 and FT2032 for the 2 parallel data, and 1 little chip only for I2C to USB. And the third solution, as I said, is to say we have 1 signal that can be displayed, shown, and displayed on the screen. We can hear, and the second is sent on an external parallel plug. And if people that want to use it to display it, it's very easy to create a very little PCB with a second FT2232 that will send the parallel data to the second USB plug in your PC, and you will see it. So, I think it will be a new solution for 2017. 17th. Right, no, not 7. Wait, 17th. 16. 16. If you want, we can. So, first solution could be a kit or a PCB, like for the MiniTuner one. And there is also a second solution proposed by Art Tosley, is to sell directly a fully assembled and tested MiniTuner Pro. So, conclusion, we have many things for playing. For testing, we can test, we can play with all these new tools, these new toys, and we will see what we can do now for narrowband DATV. Thank you.
Thank you very much, Jean-Pierre. I'm sure there must be some questions.
Yes, thank you. Really interesting. Lawrence here. Just wondered, would you be interested in having a board done for you which had an integral USB hub so that you only had one physical connection to the host PC, but it would still see several devices?
I don't understand exactly what...
Well, we'd combine the 2 USB feeds that you have presently on 2 cables into a single cable. But you could still, the host would still see 2 remote devices.
We can do it. It can be done as a kit because we need to have the 2 USB chips, FTDI USB chips, soldered on the same PCB.
That's right.
If we buy only the mini module from FTDI, they are separate.
Yes.
So,
So you have the two.
but the first question
We'll talk about
is,
it offline.
do
Yeah.
we need to use, we need really to receive and show at same time two video and audio? Do we need that?
Yeah. Who knows? Anyway, thank you. Thank you very much.
Sorry, Graham. Tomorrow we will talk about her sales set. I won't prejudge what Dave is going to say about the video side of that, but there we've got 8 megs of spectrum,
Yeah.
where there will be hopefully more than one amateur from somewhere in the world transmitting video at some level, using some data rate, using some modulation. So that's possibly an area where having more than one channel, to be able to receive more than one channel design, might be useful. I've got a question, though, goes back to ARIS, goes back to low data rate video, and where with the signals from the ISS always being the link budget being the difficult bit. You said that if you were able to filter the IQ channels at low data rates, you could improve the sensitivity, which would obviously be really, really useful. Have you got any idea of how much of an improvement you could achieve?
No.
Okay, thank you.
Sorry.
Perfectly honest answer.
I
Thank you.
suppose. So it's just we expect.
Hi, Jean-Pierre, Chris. A suggestion, could we build or design a little intermediate board so that we can take off the NIM from our existing MiniTioune, plug this in, plug the new tuner in, and there's a header on there so we can pick off the second parallel if we want to, and reuse our existing MiniTuner.
Why not?
Be a lot cheaper.
Yes, it's just you have just to create a little PCB with a plug if you have.
Would you support that development?
Yes.
Excellent.
Yes, why not? It's a good idea.
Would it be a lot?
If I had that,
Yeah, but
I'm not obliged to do that.
It seems a logical step.
Yes, yes.
yeah, but the expensive bit are the two plug-in bits, so it might not save all that much. Might save a bit of construction. So you say that the bandwidth of the NIM is 10 megahertz?
All, it's not the bandwidth of the NIM, but all zero tuner
All zero tuners.
chip I have found on the market have all 10 megahertz as the lowest bandwidth.
And does that come out as differential I and Q from that chip? So that you can, and then goes to the demodulator, so you could maybe put something in between those two chips?
The idea is to put, I don't know if you know the project I have for the Raspberry Pi to filter I and Q.
Yeah, that's what I was
Using-
thinking, the same sort of thing.
Yes.
Hmm.
The idea is to use the same kind of chip to filter I and Q.
This is probably a bit fantastic, but since you've got two sets of I and Q signals, is it possible that you could sort of combine the two signals and average them out to improve the signal-to-noise ratio?
You should have patented that idea, Albert.
The world has it there.
There is some domain when we have.
Summing and taking the difference, then adding together, whether there's some possible improvement there.
There's certainly food for thought
I
there.
think-
I think we need to move on, actually.
Yes.
I will let Jean-Pierre think about that one. We can talk about it at dinner. Okay.
Yes. I just think that if it is an improvement, I don't know why the manufacturer of the chip have not done that inside. Perhaps it's done inside. We don't know really what is inside
Okay.
the chip.
Thank you very much, Jean-Pierre.
Okay.
We will catch you later with more detail.